Okay. Hi everyone, this is Inder. I'm part of a community, Insightful AI. We are a open community of machine learning people worldwide trying to figure out insights, learn, and share with everyone. So today I have Abhishek. Abhishek is the co-founder and CTO of TrueFoundry, which is a fast-growing AI startup in the machine learning up space backed by marquee investors. So welcome, Abhishek.
Thank you so much, Inder, for having me here. It's really an honor to be here
Thank you for
and really
that.
for the.
So Abhishek, you have been working like immensely, first at Meta and now on your own startup in the machine learning ops space. I've also been, working in this space for a while. I think the first question, or maybe, which everybody would want to learn about is why don't like models go to production, right? Like we built models and it's just so hard. Like we spend so much infrastructure, so much time, talent, but if you look at the number of models which really hit production, right? Like it's probably not as what everybody or every leader in the company wants. So if you could, share like what's going on behind the scenes.
Yeah, that's a great question. I think a lot of people have questions about like why don't models go into production. So to understand that, like it's important to understand the machine learning life cycle and what goes into building a model that really has an impact. So machine learning is kind of to get a successful model in production, you kind of need like three teams to come together, minimum three teams. Like you will need like the data engineering team to come together because you need to massage all the data to get all the features and things that you need for the model. A lot of times companies don't log the data that is needed for ML. So then you have to first ask the logging to be done. Then the data engineering team will come, they will build the ETL pipelines and then machine learning process starts. So maybe like after you come up with the idea, it will pass 3 months till you have the data to just do ML. 3 months will pass there. And then after 3 months, like what happens is like once the data is then the data scientists will do some experimentation, will figure out the model. So then that is where the data science team comes in. Once the model comes out, then ML engineering team, if there is a separate ML engineering team, they will come in. They will try to convert that model to a service. And then your finally infrastructure and DevOps team will come in to finally put it to cloud. So this whole process requires collaboration from these four teams, aligning of roadmaps between these teams, getting the bandwidth and everything. And because these four personas understand different parts of the stack, there is a lot of back and forth between the different personas that, hey, this is not working, then the other person will go and fix. Then again, the iteration cycle will happen. This ends up becoming taking up a quite a long time in a company. Like imagine like 6 to 8 months or even 12 months goes before any of the model comes out as thing. And the problem with the thing is like in 12 months, a lot of things change. The priorities of the company might change, some other more impactful project might come up. And then what happens is by the time things start going to prod, like or things start to getting to be launched, some other higher priority thing comes up or something like so. Some projects get scrapped. Especially if a time of delivery of projects is so long, it's the
Yeah,
chances of that project getting shifted and all is higher. The
yeah,
second thing is oftentimes the model will meet the accuracy but not meet the SLA requirements, like the latency requirements, the cost requirements, and things like that. So if those estimates are not done prior to the project well, that okay, this is the budget for this project, this is the expected ROI of this project, you have to meet this latency. It usually results in a lot of back and forth between these different teams that further uh, results in like longer cycles. And what happens is even if the model goes to production, the backend team will complain that, oh, the latency is too long because of which customers are dropping off. So then there is always a constraint that how much is the ROI? Because the cost is there and the business is going to evaluate the return on the investment. It's possible that your cost is more than the return that you're getting out of the
yeah,
business. Uh, so those are the little bit non-deterministic factors. You can kind of solve this by doing a few best practices and all, but these are the fundamental things why ML starts becoming more complicated. It just involves a lot more moving parts with folks that don't understand the entire pipeline uh, together.
yeah. No, thank you, Abhishek. I think that is very insightful. I could also relate to some of the things that I face day to day building. As I think you stressed upon the fact that it is a non-deterministic software development process. I think we all
Yes.
have to shift from that mindset that hey, I have the requirements and I'll give you an ETA and it will launch and everything will work, to I will actually try my best on a data set and see what precision recall and AUPR I'm getting, and then I launch in production and see where I am and then iterate. So there is this cycle time required wherein there is massive investment both on infrastructure and talent upfront, and then you can launch to production and you may have nothing to show. But it's that iteration, and then you know the kind of mindset shift is needed from how we do engineering versus how we do machine learning engineering. So I think that is
Yes.
one area which I could relate to, which you highlighted. I think the other thing which you said about you know uh, which I think the unglamorous part of machine learning is data set collection and preparation, right? Like, so even I have experienced that, in general, engineers like to work on, cutting edge. So everybody wants to get to, hey, how do I deploy, the coolest architecture? Like, it could be like a multi-head neural network, or in this case, transformers. But what are you training on, and how much time you have spent in ensuring that the domain and the business context of the data set is complete. I think if we spend enough time on that unglamorous part and maybe having separate teams on that, right, like I think that can operationalize this better. I think you touched upon that second part, which is also very relevant to the challenges which you and I face day to day. I think the third part, which you probably highlighted, which is also a very big problem, is that you can train a model in an offline world, but when you take it online, the difference between predictions that you're seeing online and offline are, probably not holding up. So, have you seen like any companies using like, tooling to kind of automate, this entire workflow? And I know that you are building a startup pretty much like in that space. Maybe you could share a little bit about like what you guys are building, and how that is solving this entire life cycle.
Yeah, so we are basically, so there are a bunch of tools in the MLOps space, as all of us know. I'll just give a brief overview of the tools and then we'll come to like what TrueFoundry is doing.
Yeah,
So there are a bunch of tools like initially when you start with the, like the data pipelines and all, you have to write the data pipelines to get the data in the desired format. So for that, you have a bunch of tools in the market, like you can use Airflow, Metaflow, Daxter, Prefect, Flight. So these are all tools which kind of makes it easier for data scientists to write data pipelines without relying on the data engineering team. That's fundamentally what these tools do.
yeah,
Once you have the data, then you probably need a Jupyter notebook to work on it. And
yeah,
probably you will need Spark support, like if your data is big and all of those tools coming. So probably something like Databricks, SageMaker Studio. These are a few options that companies have. And even TrueFoundry notebooks is some options that companies have to like provide that development environment to data scientists. Because there is this key difference between ML and software, where software engineers can develop on the local laptop and everything is fine. They don't need to provide a separate
yeah,
development environment for them. But in
yeah,
ML, like you can't even run the code locally if you are needing GPUs or need high amount of RAM and things like that. So you have to go to the cloud even for development.
yeah,
Uh, that is another thing. Then after you do EDA and all, then comes your model inference. Now to do model inference, model building, there are like multiple of these algorithms. You can choose one of them to figure out the best model. And during building, you need this experiment tracking tools like MLflow, weights and biases. These tools come in to gather all the data about the model hyperparameters so that you can later go and look which model was doing the best and also maintain the lineage of the model. Uh, After that, the next set of tools comes like the model inference. So
yeah,
then you have these multiple frameworks to host the model like PyTorch, TensorFlow Surf, Triton. Nowadays, VLLMs for LLMs, Fast API. So you
yeah,
have like five, six options there. Which one you choose is the best thing for your inference. And then in the model deployment, there are multiple, again, platforms like you have SageMaker, Vertex AI. You can do it on Kubernetes. TrueFoundry is another platform that helps you build and deploy these models. So this is like the fundamental five stages, and you have different softwares kind of orchestrating different parts of it. Uh, what TrueFoundry is trying to do is basically we believe that the infrastructure layer should still be the same as software.
mhm,
The abstractions that you kind of build on that infrastructure should be ML, should be according to the ML abstractions basically. So we choose Kubernetes as the underlying infrastructure layer. So we are cross cloud. You can deploy on AWS, GCP, Azure, or even on-prem. And on top of that, we kind of build those abstractions which make it easier for data scientists to deploy on Kubernetes. So you want to deploy a Spark, you want to deploy a job, a training job, a batch inference job, you want to deploy a model inference real-time service. So all of that becomes very easy for data scientists that you don't need to involve your infrastructure, ML engineering, or your DevOps team. While keeping in mind, so one thing that we do is we also make it easy for the platform team to configure those guardrails. That you can say that uh, these data science teams should not be able to deploy from a public GitHub repository, or their code should always go through scanning and vulnerability checks. So those kind of policies you can still configure, and TrueFoundry get deployed on the customer's cloud. So it gets deployed on your AWS, GCP, or Azure account. So there is no data transfer happening outside. So everything is secure and reliable that way.
Understood. So TrueFoundry is like kind of an end-to-end platform which simplifies this entire life cycle, which we discussed, and along with governance and ease of use. Yeah,
Yes.
yeah. I think these days everybody's trying to build either fine-tune a large model, or build a RAG on top of it, or probably build a foundation model. But I would say probably a few people are trying to do the last one. So
Yes.
how do you think like the space is evolving when we have to host the large multimodals built on transformer decoder? Like, is the tooling same, or is it evolving? Then what to watch out for? What is working?
Yeah. So yeah, I think with the advent of Gen AI, like the ML world is changing quite a lot.
Yeah,
Uh, so the first thing is the number of ML applications is going to grow drastically, and
yeah,
it's already starting to happen.
yeah,
Like places where people never thought about using ML, like every company is doing ML now.
yeah,
Uh, it might be just calling an API, but at the end of the day, there is you'll call it ML only. It's
yeah, yeah,
happening,
yeah,
right? So number of applications is going to grow drastically. The second thing that is happening is in a lot of cases, ML has been resolved to using APIs. So
mm,
it's starting to look more like software in the at least when you're making the demo.
yeah,
You just use the OpenAI or some Cohere APIs, and then you can have a very nice demo. In vector DBs, in RAG, you need like a vector DB and one more component, but that is also very similar to software. There's very little, you don't really need to have any ML knowledge to build a RAG system today, like at least the demo part of it. But what we are realizing is like as you start going into production, there will be some components that you would want to have this foundation model, some components where you would want to have this statistical ML models, and some just even like normal software engineering. So I think the term compound AI system has become really, really popular nowadays. And that's what people are realizing, like to build something that really has an impact in production, you need to bring all of this together to build like a very, very smart system.
mm,
Uh, and so that's why like uh, we feel like this the ML development is going to grow like much, much faster. And it's also becoming more complicated. To answer your question about hosting the foundation models and all, it's the same as hosting those models, except that models have become really, really big.
yeah,
So your infrastructure choices slightly become slightly different. Like number one, you have to use GPUs. So the number of GPUs being used now is
yeah,
much larger than the number of GPUs used 5 years ago.
yeah,
So GPU engineering comes with its own challenges.
yeah,
Like how do you fix out the GPU, which GPU to choose? GPU availabilities might be a problem. So you might have to switch cloud providers or do multi-cloud and things like that. So that is one problem. The second problem is because these models are big, how do you run inference on them in a very, very fast pace and in a most optimal way?
yeah,
Uh, all those optimizations start coming in, and there are like so many technology, like we have VLLM, we have TGI, or multiple ways of and Triton of hosting this model. So which one do you choose?
yeah,
And everyone performs better in a certain model, but not
yeah,
in every model. So the number of choices, the number of moving parts is only increasing over time. So you still need software, you need still need ML, and now you need Gen AI models. So your systems are now having like three components instead of just one or two.
yeah.
So it's becoming more complicated to build systems, but it's also giving the systems much more power than it used to have 3 years ago. Now the softwares that will get built, they will be much, much more smarter than what we were building like 2, 3 years back.
Mm. Yeah, no, I think that's very insightful. I know, I mean, like, on one end, we are getting like large foundational models, and on the other end, there are smaller models like Phi 3 and Llama, which you can host through VLLM or OLama on your laptop. Uh, so I think as there is explosion and fragmentation which comes here, right? Like ability to provide similar abstractions that, to solve problems like building a compound AI system requires like being able to choose the right model, maybe run more than one
Yes.
routing problem. So all of this comes into effect. I can totally relate to what you're saying. We are trying to build like a, in my work, uh like a project which is like a, simplistic rack for a, uh, uh you know for our internal business. It turned out it's not so simple. Making it work, and then deploying it and scaling it, and then obviously the cost benefit analysis. So, uh, so I'm hoping that probably, your platform will extend into, that space, and you will probably, simplify and abstract that for everybody, like people like us, going forward. Is that the plan?
Yeah, yes, we have started to do that. So a lot of LLM abstractions are also coming onto the platform. We have a gateway that allows you to talk to different LLMs. We have a RAG template also that allows you, makes it easy for you to build. And we open sourced it. It's called Cognita.
Yeah,
So that's also open source, a RAG template that can allow you to build this RAG applications easily. And I would just like to touch upon that cost implication thing that you mentioned in the like. I had a
yeah,
very interesting experience recently with one of our customers. So they built this demo nicely of a chatbot and everything was working great, right? But when they evaluated, so and they were using like this Azure OpenAI models and everything looked good on paper.
yeah.
And when they decided that they want to launch in production, the cost estimate of that project came out to be $300 million.
Wow.
Uh,
Wow.
so
Yeah,
per year. So now the thing is like the business is like there's no way we can justify the cost of this project, right? It's a chatbot at the end of the day. It's not going to increase the revenue by $300 million, right? And that was using Azure. So then they had to like revamp the entire project to train these smaller models to give higher accuracy, and they were able to reduce the cost from 300 to $10 million. So
wow.
that's the kind of impact it can. But they had to do a lot of fine tuning to get these smaller models adjusted to the use case. So now the cost of, and they also started hosting their own GPUs and just brought it down to their own GPUs, hosting it themselves instead of using a foundation model API, and they were able to reduce the cost drastically. And now it meets the business requirements. So that is the cost difference we are looking at. So it's
Yeah,
not.
that's like insane, right? Like, I mean, $300 million to $10 million. But you're right. Like, I was speaking to someone, and they also mentioned that how to choose between RAG and fine tuning. And I think people are trying to do both. Like, I was speaking to a friend, he was explaining that, we are fine tuning it on our data set, and then we do RAG on, knowledge which is kind of mutable, which changes, like, and with fine tuning, they are overfitting, and, they want that to happen, and pruning the models, as you rightly said. So yeah, I think uh, that is the direction which is going, but that makes it more challenging because then suddenly, you can't use only one model, and which model to fine tune, how to even do eval, right? Like how to write unit tests on this. Like these are like very big open-ended problems. So uh, yeah, very exciting. I think you guys are building in a very interesting space, and lots of opportunity, and doing very great work. Yeah, we are very proud, all of us in the community.
Thank you so much, Inder. We would love your support and everything. And it's because of the support that we've got from our friends and other entrepreneurs that we have been able to make the progress. So hopefully, and it's an exciting time for all of us to build at this point. Like it's probably once in a lifetime moment for all of us. So we should all use it and build those applications to bring the greater impact.
Yeah. Thanks, Abhishek. It was very insightful. Thank you for taking the time, and have a good day. Yeah, take care.
Thank you,
Bye.
Inder. Thank you for having me here.